Hello guys, welcome back to my channel. So in this video, I'm going to present a new machine learning project that is heart disease prediction. Coming to the table of the contents, first I'm going to explain the brief introduction of what is heart disease. Second, what are the contents or steps are involved in this project. Third, I'm going to explain the timeline of the project. Fourth, what are the libraries are importing in this machine learning coding of this project? Fifth, what is the flowchart of the project? And sixth, web app predicted model. And lastly is the conclusion. Coming to the introduction, a heart attack occurs when one or more of your coronary arteries became blocked over a buildup of fatty deposits, including cholesterols from substances called plaques, which can narrow the arteries' atherosclerosis. This condition is called coronary artery disease that can cause more heart attacks or heart diseases. First, you have to understand that what is heart disease. It is also called as coronary artery disease, or simply heart disease involves the reduction of the blood flow to the heart muscle due to buildup of atherosclerotic plaque in the arteries of the heart. It is the most common of the cardiovascular diseases. A common symptom is chest pain or discomfort which may travel into the shoulder, arm, back and neck or jaw. Occasionally, it may feel like heartburn. Usually, symptoms occur with exercise or emotional stress, last less than a few minutes and improves with rest. Coming to the contents or steps which are involved in this project. First, we are going to import the libraries. Second, we are going to import the dataset. Third, that we can analyze or visualize the dataset. Fourth, that we can standardize the data by using data scaling methods, that is min-max scalar. Fifth, we can create different machine learning models by using ML techniques like random forest, decision tree, grid search CV, AdaBoost satisfier, and many algorithms which we can do it. Next, we can store the ML models in pickle module. Next, we can predict the final values of this project. And lastly, we can deploy the final web app predicted model. This is the timeline of the project which I already discussed in the previous slide. So let us move further to the next slide. So what are the libraries I'm going to import is pandas, numpy, seaborn and matplotlib. Seaborn matplotlib is for visualizing the data. Numpy is for showing the arrays of the dataset, whereas standard scalar is used for data scaling. Logistic regression, support vector machine, decision tree, k-nearest neighbors, random forest, AdaBoost classifier is are the ML module, ML algorithms which we're going to show the final accuracy score and different confusion matrices and different accuracy scores we can predict in this project. Coming to the flowchart of the project, first we can open the web app and we can fill all the details. After filling the details, then you can click the predicted button and it shows the predicted result value, whether the person is having a heart disease or not. For chances, if you not fill the details, please, it's very mandatory to fill the all details to show the predicted result. Then you can click the predicted button, then it shows the final predicted result value, if that person is there in a chance of heart disease or not. Coming to the web app predicted model, model deployment is the last stage of the heart disease prediction machine learning project by using Flask to make a HTML file of heart disease prediction. This will take the input values of each and every person that gives the predicted result. So this is how the web app prediction model works. The user sends the request features and goes to the HTML web page. Then HTML web page goes to the ML module. After the ML module was predicted, then it goes to the HTML web page, and finally goes to the response for a final predicted value or result. So let us start the machine learning code of this project. First, we have already uploaded this dataset here, that is hard.csv. When you just download this dataset, and I'm going to show you the dataset. There you go. I have this total 14 columns in this dataset, that is age, sex, CP, TRTBS, cholesterol, FBS, ST, SCCG, TALAG, ESNG, old peak, SLP, CAA, TAL, and output. So these are all 14 columns in this dataset, and totally they have 303 rows in this dataset. So first we are going to understand the each and every column in this dataset. First is the age column. What are the age of patients? It is defined in the integer data type, whereas sex means gender. The person is a male or female. Coming to the exam means exercise induced angina. The 1 is yes, and 0 is for no. CA means the number of vessels up to the range of 0 to 3. And next is this chest pain type, the totally 4 values. Value 0 is for typical angina, 1 is for atypical angina, 2 is for non-anginal pain, and third is for asymptomatic. Next, TRT BPS means resting blood pressure, CHOL means cholesterol in mg dash derive fetched in BMI sensor. FBS means fasting blood sugar which is greater than 120 mg DL. 1 is equals to 2 and 0 is for false. Coming to the rest, ECG means resting electrocardiographic results which were shown in the electrocardiogram. One is where this was normal, next is having an ST-T wave abnormality, and lastly is showing the probable of defining a left ventricle hypertrophy by each criteria. Next, TALAG means maximum heart rate which is achieved, and lastly whether the target or output which is 0, it shows less chance of heart attack, and 1 shows there is a more chance of heart attack, which will show in the final output. Next is TAL. TAL means exercise thallium scientific defect, and slope column is for the peak exercise ST segment, that shows 1 is for upsloping, 2nd is for flat, and 3rd is for downsloping. And next is the old peak. Old peak shows that ST depression induced by exercise relative to rest. So that's it, guys. So first we have to understand the data set, and then we can proceed the machine learning coding. First we can import the libraries, then we can mount the Google Drive. There you go. So mounting the Google Drive is compulsory. There you go. The Google Drive is mounted. Next, we can have the dataset, that is hard.csv I have shown in the dataset. We can import the dataset and we can display the dataset. And next we can show the information. As you can see, total 14 columns are there in this dataset. In 14 columns, other 13 columns were in the integer data type, whereas only the one column that is called as old peak is in the showing the float values. Coming to the day-of.shape is totally 303 rows and 14 columns in this dataset. Next, in this dataset, is there any null values are there? There is no null values. Let us proceed further. And these are the data types in this dataset. Next, is there any null values are there? There is no null values. Let us go for proceed further. Next, there you go. I wrote like this. There is no null values in this dataset. Next, in third part, we can do some analyzing and visualizing the dataset. First, I am going to display the correlation matrix of this dataset. There you go. Next, I am going to show you the heat map of the dataset. There you go. Next we have to plot a bar graph of gender, where 0 is for female and 1 is for male. Just you have to run this. As you can see, the female is only 96 and male patients are 207. Okay. Next, we can plot another bar graph for exercise thallium scientific graph, that is thal column. That is 1 is for normal, 2 is for fixed and 3 is for reversible effect. Whereas a default is also there. Default is only 2 and 1 means normal, which is in 18, whereas 2 means fixed defect, which is in 166. That is the highest to plot in this bar graph, whereas the third is 117, that is reversible effect. Next plot is for slope of the exercise ST segment, that is the SLP. Just 0 is for upsloping, 1 is for flat and 2 is for downsloping. Here you go. Whereas the upsloping shows only less, whereas only the downsloping is the highest plot in this bar graph. This total is 142, whereas the flat shows only 140. Coming to the next bar plot, where the number of major vessels colored by fluoroscopy that range between 0 to 4. There you go. When you just run this, highest range is the 0 range, which is in 175. Next, we can plot another bar graph for induced angina, when 1 is for yes and 0 is for no. There you go. This is the highest plot, which shows only 204. For 0 means 100% no, whereas the 1 shows yes, is in angina is 99. Coming to the next one, we can plot a bar graph for resting the electrocardiogram results. Means it shows the result of by using the electrocardiogram, that is the device that shows the ECG signals. 0 is for normal, 1 is for having an ST-T wave abnormality, T wave inversions, and ST evaluation of depression, which is greater than 0.05 MV. Whereas another one shows the probable of defined left ventricle hypertrophy by Easter criteria. Just you have to run this one. As you can see, there you go. The first one shows the having ST-T wave abnormality is the highest plot, which is in 152, whereas normal is 147, and the lowest is showing possible of defining left ventricle hypertrophy by each criteria is the lowest plot in this bar graph. Next, we can plot this histogram. There you go. As we have our variables are not highly correlated to each other, we can do some uni and bivariate analysis for our various features. So this is the plot of age of patients which are there in this heart disease prediction dataset. Next, we can plot deeply for the age including the gender, that is sex. Sex means gender, that is for male and female, whereas the 0 shows only female, 1 shows only male. Highest in this patients is the male patients are the highest. I told you the male patients which are in 207 and 0 means females, but shows only 96 patients, female patients. Next, we can plot a bar graph of chest pain, guys. Chest pain you can see, whereas the typical anginas, 0 shows typical angina, which is in 143, which is the highest. When you can observe in this bar graph, Jaigo, this is the highest plot in this bar graph of typical angina, which is in 143, guys. CP means chest pain. Next, we are going to plot the ECG rest electrocardiogram like this. Like there you go, 152 is the highest. When you can plot the bar graph, you can observe the normal is the highest. There you go. Next, we can plot the pair plot of this output in this dataset. So this is our ECG data for this one. This is the ECG data of patients. So it will take some time. There you go. So this is the pair plot of this heart disease prediction of the dataset. Next, let us see for our continuous variables. You can observe the first plot. I am going to show you the left blood pressure. This is magneta, and TL color, magneta color is magneta means pinkish color, whereas in this color it shows TL, which is in light green. This is also shows in another plot. When you run this, there you go. This plot you can be observed like this. Next, I am going to plot a cholesterol where I have inserted a color which is red. You can observe like this. Here you go. Next, I am going to do some standardization of this dataset by data scaling. Scale short form is data scaler, and we can fit this model here. Sorry, we can fit the dataset into this model. Next, we can print the shape of this dataset. There you go. Lastly, it shows the, we can show the display of the dataset like this. Yeah. Next, we will use the following models for our predictions. ML models like logistic regression, decision tree, random forest, k-nearest neighbor, and support vector machine. First, we are going to split this dataset like this into X label and Y label. There you go. This is X label, and Y is the output. Why am I doing this? X label is the dependent, whereas Y label is the independent variables. So this is the showing like this. That's why I'm splitting the dataset like this. Next, I'm going to train test splitting the dataset like this, whereas the random state is equals to 101. First ML model I'm going to show you is the logistic regression. First, I'm going to import the logistic regression ML model, and then we can fit the model. There you go. The model is already fitted, and don't run this y equal to pred1 y prediction values. It shows only y prediction values by using numpy array. Means no. Why am I not running this? First, you have to run this accuracy score and confusion matrix. Actually, this numpy array, it shows the like confusion matrix. First, you have to run this accuracy score confusion matrix by importing this, and then we can transform the y-test values, and then run this. Another y-test value is equals to log rate. Log rate means logistic regression. We can predict the s-test values, confusion matrix, and accuracy score also. There you go. Then you can run the toughest one. There you go, like this. So next, I'm going to show you the confusion matrix of the logistic regression. In logistic regression, as you can see, the accuracy score of the logistic regression is 85%. Next, I'm going to deploy the decision tree. Tree short form means decision tree, and we can fit this module into this dataset. And ypred2, for ypred1 is for logistic regression, whereas ypred2 shows decision tree. Right. Next, I'm going to fit this model by test values. Next, I'm going to import the confusion matrix and accuracy score of this decision tree. There you can observe 81% is the accuracy score of decision tree. Coming to the next one is the random forest. RF is the short form of the random forest, and we can fit this model in this dataset. And ypred3 shows the random forest. Confusion matrix and accuracy score of the random forest is 81%, whereas in decision tree is almost same. I will edit here. There. Next, I'm going to import another ML module, that is k-nearest neighbors. First, I'm going to import the k nearest neighbor library and then write this code. You can fit the training and testing module of the dataset like this, and we can plot this k values, error rate, and to check the correct value of the k fold of this dataset. Here you go. The error rate is the X label shows k value, and error rate is the Y label. Error rate shows Y label and k value is the X label, like this. Coming to the next one, we're going to fit again for confusion matrix and accuracy score of the k nearest neighbor. As you can see, the k nearest neighbor is also same accuracy score related to logistic regression. Coming to the next is the SVM. SVM means support vector machine, whereas the SVM is .svc. SVC means support vector classifier. We can fit this model right now, and YPrep file shows the support vector machine. Then I am going to show you the accuracy score of this support vector machine, whereas the support vector machine shows only 84.61%, which means we get the highest accuracy score of 85%, that is logistic regression and KNN. Both the ML modules shows 85.71% of this accuracy score. I got. Next I am going to predict the model accuracy scores by relating to other ML modules. There you go. Logistic regression and k nearest neighbors are having the same accuracy score, but both the ML modules are highest ML modules. Like this. There you go. Next I am going to import the another ML module, that is ADA boost classifier. ADA short form reads ADA boost classifier. We can fit this module, and YPrep says means ADA boost. I am going to show you the confusion matrix like this, and next is the another accuracy score of this ML module. 51.64% is the accuracy score of ADA boost classifier, which is very less accuracy score related to the other ML modules. Next is the grid search CV. There you go. Both the ML modules are same accuracy score, but both the ML modules are higher related to other ML modules. Coming to the parameter grids. There you go. Parameter grid search CV. There you go. Yeah. I fitted the module logistic regression model in grid search CV, and what are the best parameters are like these values. These values are the best parameter values in the grid search. Coming to the next, I am going to fit this model again, and I am going to show you the confusion matrix of this dataset. There you go. The 83.51% is the logistic regression which are imported in grid search CV. Next, I am going to import the neighbors, and we can import the weights like uniform, distance, and coming to the metrics means Euclidean distance, Manhattan distance, and Minkowski distance. But these three distance we already know in data mining, guys. Which we are going to import this SQLM model selection, that is repeated stratified k-fold. K nearest neighbor shows in k-folds. When you can import the grid search module like this, it will take only little time. There you go. We have already imported. Again shows the best parameters for grid search is this one. Next is the k nearest neighbor classifier, where the matrix is Manhattan distance and weights is distance only, and we can fit the module, and we can show the confusion matrix. As you can see, 85.71 is the best accuracy score. We can run again. That grid search CV is, or we can estimator is support vector classifier by importing fitting the model in grid search CV dataset. There you go. The best parameters is this one. you are going to run again the importing the SVC, and then you can SVC model is also fitted, and we are going to show you the accuracy score and confusion matrix of this support vector classifier, that is a support vector machine. There you go, the same accuracy score, that is 85%. Lastly, the final weighted means the final accuracy score I'm going to show you. First, I'm going to fit the model of logistic regression, Y predicted values, confusion matrix, and lastly the accuracy score including the confusion matrix of the model, that is 85.71% in this heart disease prediction of this project. There you go. This is the confusion matrix of logistic regression, that we can know the person is having a disease or non-disease of the heart prediction. Next, we can import the pickle file and dump the file, that is heart.pickle, in write binary. Lastly, I am going to show you the final output of this project. So just I am going to show you in Visual Studio. There you go. So I am open the Visual Studio right now. So this is the Visual Studio, and I have run this app.py, and this is the folder called heart disease prediction. From we first time imported the Flask render template, which is request. Render templates means index.html. It shows the front end of this output. Next, I imported the pickle file, import the numpy. Next, the file name is heart disease prediction as knnmodel.pkl. There is a pickle file. That is the file name of this output. Model equal to pickle, loading the pickle file, that is in form of read binary. Pickle contains two types, write binary and read binary. There you go. Because you have to return the values in this render template, that is main.html. And next, coming to the next, this in the methods, there is get and post in this Flask. Flask can have two types. First is get and post. We are going to request the method that is to post the final output value of this project. So these are the columns that we are going to select in this select box, and we have to predict the final value also. So next I am going to run this code. Then you can observe that I got this HTTP. Just you have to control click, and it shows this output, that is heart disease predictor. Then you can see that we have got the model accuracy score is 85.71% accuracy, is the good accuracy. So let us go into select the patient of this project. I am going to select the patient age, which is 40, and gender, which is male, and chest pain type, which is typical angina, whereas the resting blood sugar, which is in 96, serum cholesterol, which is in 120, whereas fasting blood sugar I am going to select which is greater than 120, and ECG these results, which is in having any SCT wave abnormality, and maximum heart rate I am going to select which is 110. And next, exercise include angina, which is yes, and ST depression, which is in 4. Next, slope of the peak exercise ST segment I am going to select is upsloping itself, and number of the major vessels is 0 only, whereas thalassemia, which is a normal. When I am going to click on predict, you can observe that you have a chance of heart disease. Coming to the conclusion, we have understand that I am able to apply machine learning algorithms and use to predict the heart attack probability of the patient by inputting the diagnostic test results. With this help of ML techniques, my model was able to predict the accuracy score of 85.71, which is good and reliable. the prediction of the training data is compared to the prediction of the testing data by applying all the ML techniques or ML modules and operations to make the final prediction of the ML module. I hope you like this video. Thank you. Thanks for watching.